Hey HVAC techs, I'm Greg Fox, and today we're going to talk about adding more refrigerant to an air conditioner. I wanted to expand on our recent troubleshooting series by going into each part of its sequence of operation. This week, it's the refrigerant. Let's go over some of the basics to charging an air conditioner on your average 90-degree day in the middle of summer. Upon arrival at the house, your customer tells you that the air conditioner worked just fine last year, but this year the system seems to be running non-stop, especially as the summer days get hotter and hotter. You ask the customer, have any other technicians been out to make repairs on the system lately? And it's very likely the customer will say no. There's a lot of things that can affect the refrigerant charge. Just remember, for the sake of time, we're trying to keep this dialogue short so that we can get to the point of charging the system up. I like what Brian Orr from HVAC School mentioned in an article I read. He said, we need to set up the equipment so that it won't freeze during normal operating conditions. At the very least, the typical residential AC system should be set up so that the return air temperature can get all the way down to 68 degrees and still be just above freezing at the evaporator coil. Let's say it's 78 degrees in a house on a 410A system and your suction pressure is 108 psi. That means that your suction saturation coil temperature is 35 degrees, so the coil won't freeze. However, the coil temperature will drop approximately 1 degree for every degree the return air temperature drops. Remember, at 78 degrees inside, the evaporator coil was 35 degrees. So if the customer sets it down to 74 degrees, the saturation temperature would get all the way down to 31 degrees, and the system will start to freeze up. Knowing this, let's grab your temperature probe and check the return air and the supply air. Here you notice the difference between the two is about 8 degrees. As a tech, you know that the temperature split should be around 18 to 22 degrees. Next, let's head out to the outdoor unit to feel if the suction line is cold. Now, there is some validity to the old term beer can cold, but it should not be the measure that you go by to check the refrigerant charge. It can, however, give you a clue as to how the condition of the system is running. Now, I'm not always a huge proponent of hooking gauges up to a system every time I go out to diagnose a problem, but in this case, we can tell that there's something not right with the cooling system. So in this case, I want to see what's going on inside of it. Hook your hoses up to the liquid and suction lines. Be careful of blowback too. You don't want to freeze your hands. Follow all the safety precautions you've ever learned. Now, what do you see on the suction side? I like my techs to talk to me about the evaporator coil temperature and the temperature of the condenser coil. When I'm on the phone trying to help a tech out in the field, it's hard for me to remember all the pressure-temperature ratios between the different refrigerants that we use. So if someone tells me that the evaporator coil is 40 degrees, I can immediately tell that the coil is not freezing. If someone tells me that the temperature of the condenser coil is 140 degrees, I can immediately translate that to an outdoor coil that is under some seriously high pressures. On the refrigerant gauge, the outer circle and those numbers are the pressures. The inner ring of the numbers reflects the temperature. This is how I want my techs to communicate pressures to each other. It's just more efficient that way. Most gauges these days have a green ring for R22 and a pink ring for R410. The pink ring's numbers are what we're using for the evap and condenser coil temperatures on a 410 system. Here we see that the evaporator coil is about 20 degrees. For proper refrigerant levels, the image that I want you to project in your mind is this. Our end goal here is to have liquid refrigerant reach all the way to the TXV at the evaporator coil to meter the refrigerant appropriately. Right now, there's not enough liquid into the system to do that. This means that vapor is making its way to the metering device, and we're not giving the coil enough refrigerant to interact with the speed of the blower air moving across it. We need the perfect balance of airflow and refrigerant pressures to create that 18 to 22 degree temperature split that we're looking for. Let's suppose that the system holds 10 pounds of R410A. Now, in my mind, I'm thinking the system is about halfway charged from what we've seen so far. It's an approximation, but we have to let the customer know about how many pounds that we're wanting to add so that they can give you the okay to move forward. Of course, you don't know for sure how much it is, but they should be aware that it could be around 5 pounds. We need to let them know that it could be a couple pounds more or it could be a couple pounds less, but either way, we need permission to move forward. Using a scale is the only way that we know for sure how many pounds of refrigerant that we're adding. And it's cool to let the customer know that you'll be using this too. It's reassuring for them. This is also great in preventing you from overcharging the system too. Okay, so my service hoses are already hooked up. I'm going to start by putting my charging hose onto the tank of the refrigerant. Next, I open the refrigerant tank valve and place it upside down on the scale. With the gauges closed on the manifold, I crack open the connection where the charging hose meets the manifold. Not too much though, we just want to get the refrigerant to prime itself up to that point so that we can get rid of any excess moisture or air in the hoses. Reset the scale back to 0 so that we know how much we are adding as the refrigerant enters the system. I recommend that you put an amp clamp on one of the wires leading to the compressor too. If you've seen my videos on diagnosing a bad compressor, you know that the compressor's amp draws correlates with the refrigerant pressures inside the system. The healthiest compressors will run at around 60% of its RLA. When you're charging up the system, you'll see amp draws fluctuate as the refrigerant goes in and settles down. Use your knowledge about the compressor amp draws to monitor your charging process. Okay, we're ready to charge. With the charging hose valve open, we'll start opening the suction side valve. A quarter to a half a turn is enough. There's no approximate amount of time it'll take to insert 1 pound of refrigerant. Each situation is different. To know for sure, use your scale. In this situation where we think the system is about 4 to 5 pounds low, let about 2 pounds flow into the system and wait for 5 to 10 minutes for the system to equalize. Question: how long does it take for the refrigerant to cycle through a typical residential split system? I'd say about 3 or 4 minutes. If you have a different answer, let me know in the comments down below. So we see now that the low side has come up to about 27 degrees or 92 psi. Our evaporator coil is still freezing. Let's add 2 more pounds and wait. I know there's a lot of pressure on techs to get their calls done quickly so that they can get on to the next one, but it's essential to let the system stabilize before adding too much refrigerant. If you add too much too soon, you could see the pressures skyrocket insanely fast. And now you have to recover some more refrigerant into a separate tank, which takes even more time. Okay, now we're getting close to 32 degrees or about 100 psi on the suction side. From here, we want to start dialing in our subcool to whatever it is that the manufacturer recommends. This system says 10 degrees subcooling on a 95 degree day. Let's get a temperature probe on the liquid line and start getting our reading from it. We're going to be subtracting the high side's temperature and the liquid line's temperature to come up with our subcooling. Add refrigerant a little at a time until the difference between those two numbers is 10 degrees. Just don't add too much too fast. Add refrigerant and wait for the numbers to stabilize. You're going to be looking for the low side pressures ultimately to come around 40 to 42 degrees or 125 psi. The high side pressure temperatures will likely settle around 15 degrees above the outdoor temperature. So on a 90 degree day, you may end up with a high side temperature around 105 degrees. If you can get your numbers around this area, you're close. But let's really get it dialed in and get that subcool to 10, plus or minus 2 degrees. I will tell you, it takes longer to move the needle on your gauges when there's less refrigerant in the system. As the system starts getting close to proper subcool, you'll want to finesse the time that you keep the manifold open, allowing refrigerant into the system. Overcharging can happen quickly, especially on a hot day. Getting close to your 10 degree subcool? Cool. Once you get it to this point, check your temperature split inside. Is it around 18 or 22 degrees? Great. You'll notice that the liquid line is a little bit warmer than the outdoor temperature. Also, the suction line will be damn near beer can cold. Test the system while it's running. Get your amp draws on the condenser fan and the compressor motor. Cycle the system on and off of the thermostat to make sure the system is operating correctly. And if it is, you're good to go. Well, I hope this has helped you when it comes to the charging process. I make my videos for my technicians to reference when they're out there in the field and they're in a bind. But if this can help anybody else, that's great. If this is your first time watching our channel, please click subscribe down here on the bottom right. And if you click that little bell next to it, you'll be notified of all of our videos as they come out. Thanks so much for watching, and we'll see you on the next video. You're watching Fox Family Heating and Air. Don't forget to subscribe. And check out more of our videos by clicking on the right side of the screen.